Bismillahirrahmanirrahim. Now we will continue discussion on tutorial 4. Refer to question number 5. Based on the graph, find the Hamilton circuit, Euler path, then draw two spanning trees from the graph. So here we have three questions to be answered. So the first one is finding the Hamilton circuit. So when we are talking about Hamilton, meaning that we will consider about the vertices, right? We need to visit all vertex that we have in the diagram or in the graph. When it is about circuit, we are going to consider it must be the closed path, and then starting and ending point should be the same value, the same nodes, right? Okay, so let's check on the Hamilton circuit first. So this question refer to this graph now. We need to visit all vertices that we have. So let's say now we start with this A. Starting with this A, we may go to B, then C, D, E, F, G, and going back to A. So with that, we visit all vertex that exist. So here we visit for B, C, done, D, E, F, G, all vertices, right? So we may write the solution as A to B to C, D, E, F, G, and going back to A. So the starting and ending vertex share the same value. Okay, that's for Hamilton circuit. Second is on Euler path. So when it is Euler, meaning that we are going to check all edges. Okay, all edges in the diagram. And when it is path, meaning that we will check on the odd degrees. Okay, so this odd degrees need to have exactly 2. Exactly 2 odd degrees. If we cannot find 2 exactly odd degrees, so meaning that we cannot even find the Euler path in the given diagram. So let's check this one. We can find it or not. So if we check here the number of degree first, we may check. Nodes of A, we just have 2 degree. B is 4 degree. C is 3 degree. So now we find 1 with the odd degree. So D is 2. 1, 2, 3, 4, and here is 4. 1, 2, 3, 4 again, and this is 1, 2, 3. Okay. So now we already found 2 vertices with the odd degree. Okay. So the starting value and the ending value must be this either 2, either the nodes of F or nodes of C. So let's say we want to start at this F. Okay, so from F, we may go to E, let's say, then we can go to D, go to C, go to E, going to G, then to this F, to B, G, A, B, then going to C. So when we start, we have go through all edges or arcs that exist. So that's the answer for Euler path. Okay, so we may write here, this is the starting nodes and this is the end nodes. Okay, so just now we start from F to E to D to C, Going back to E, then G, F, B, G, A, B, and C. So this is the answer for Euler path. Okay, with that we settle for Hamilton circuit and also Euler path. So we have another equation to settle here. Draw two spanning tree from the graph. Okay, so to draw this spanning tree, we need to know what is the spanning tree first. So it is a spanning tree when it is a subgraph of 3, right? Subgraph of the given graph, sorry. So when it is a subgraph, and the second condition is we need to know that you will consider all the nodes. Okay, must contains all nodes. And the connections of that with the minimal edge. Okay, this is the properties for the spanning tree. So now let's draw the spanning tree for this graph. Let's say now we want to start with, you can choose any nodes. So let's say I choose the B to be as the rooted. Okay, so from this B, we may have it connected to A, then connected to G, connect to F, and it also can connect to C, right? Okay, so whereas we miss for this E and D, right? So we have 1, 2, 3, 4, 5, 6, 7. So this 3, 1, 2, 3, 4, 5, 6, 7. Okay, so this is one of the spanning tree. So the question asks you to draw two spanning tree. Okay, so let's say we want to draw another spanning tree. We may choose any nodes that we want to take as the values. Let's say we want to start at D, for example. Okay, so we may start at D. So this D must be connected to C and also E. We cannot make it, let's say you want to connect this D with A, for example. So no, we cannot do this, right? Okay, so D is connected to C and also E. And this C can be connected to B. You can also connect it to A, G, and F, right? Okay, so this E, now we have 1, 2, 3, 4, 5, 6, 7. Okay, so all the nodes have been included. So that this is the second example for the spanning tree. Okay, so I will erase this one. Okay, so this is the answer for the two spanning tree for the given graph. With that, we settle for question number 5.